Hey everybody, Mr. Barry here. Last video for our standard form nearpod. We've done an introduction on standard form of a quadratic function, as well as two different problems where we were graphing. Of course, we have a situation here where we're going to do an application problem, so we're able to kind of pick out certain things from the word problem and apply it to what the questions are going to be asking us. So I'll take a moment here if you're one of those folks, and hopefully you are one of those folks that are taking the time to write down the questions so that they have them for their notes. That's a great idea. So I'll go ahead and read them off here. You toss an apple up to a friend on a third-story balcony. After t seconds, the height of the apple in feet is h is equal to negative 16t squared plus 38.4 plus 0.96. Your friend catches the apple at its highest point. Three questions we have here. First one is, how far off the ground does the apple start? How long does it take the apple to get to your friend? And then finally, at what height off the ground does your friend catch the apple? So with these, it's important to know that since we have this in standard form, it might not be a terrible idea for you to figure out that first we should write down what the standard form of a function is here for the quadratics, as well as what we can get information from that right off the get-go. So I have our function right here. We know that our a value is going to be this negative 16. We know our b value is 38.4. I meant to take a moment here to write our t. Sorry about that. And then a plus sign. T and then a plus sign. And then finally, C would be 0.96. All right, so just so that we're all aware of that, I'll pull back again here because I missed that last t. So our function here is h is equal to negative 16t squared plus 38.4t plus 0.96. So we have our a value, our b value, and our c value here in this problem. How far off the ground does the apple start? So a couple of key phrases there. In that situation, the first thing that I see here is a question of how far. All right, our two things that we have within the function here is t is time, h is an amount of seconds. Excuse me, h is an amount of feet or a height measurement. So since it's asking for us for how far, we know that we're trying to solve something here for height. And we also know one of the key words in that sentence right there is the phrase start. When it comes to standard form problems, and when it comes to starting, we're aware that it's incredibly easy to figure out within a standard form of a quadratic function the initial starting point of anything. And since this is the start point right here, what we're looking for is the y-intercept. So we need the y-intercept here. And in this problem, we know that our y-intercept is always our c value. In a standard form of a quadratic, it is always going to be our constant. So here, we know it's 0.96. Since it's a measurement of height, we're talking about feet here in height. So it's 0.96 feet off the ground. As our answer to the first problem. Secondly, it says, how long does it take the apple to get to your friend? We do have to realize here, going back to our whole beginning scenario, that your friend catches the apple at its highest point. And the big concept here is the highest point. Whenever we see any type of phrasing with highest, we know we're talking about a maximum. Since we're talking about a maximum, and within the question here we're saying how long does it take the apple to get there, we're talking about time. So here in this problem, we're trying to figure out a measurement of time. And t in our function is kind of taking the place of our x values that are usually in there. When it comes to x values and when it comes to a maximum location, we're talking about the axis of symmetry, which is the x value for the vertex. So we need the axis of symmetry here. For us, with standard form quadratic functions, we know we have a very, very specific function that we can, equation that we can plug in for. We know we have x is equal to negative b divided by 2a. We know what our b and a are. We already did that. Labeled those things in that function. It does involve decimals, so we want to be careful. B value here is 38.4. And a value here is negative 16. Got to be careful to make sure we spend some time here with these negatives as well. Clear some things up. 2 times negative 16 on the bottom would give me negative 32. I have a negative divided by a negative. I have a 38.4 divided by a 32, so I'm going to definitely have to grab a calculator. And when I do that, 38.4 divided by 32, I'm going to get 1.2 as my answer. Again, going back into the question, it does say how long does it take the apple to get to your friend. We know that our x value is just an extension of t in this function, and t is talking about time in seconds. So final answer here for the second problem is that it's going to take us 1.2 seconds, or it's going to take the apple 1.2 seconds to travel to the friend. Finally, it asks, at what height off of the ground does your friend catch it? Again, the catch is happening at the highest point. Since we're at the highest point, we know we have the maximum. We're talking about height here. Height within our function is replacing the letter y. So when we see the phrasing what height, we know that we need to get the y value for the vertex. Very conveniently, within the context of asking these questions, we just found the x value for the vertex, and that was 1.2 seconds. So now that we know what the x value is for the vertex, we can certainly take 1.2, plug it in for t, and figure out what that y would be, or in this case, what the height would be at the maximum location. So I'll take the function, and wherever I see the letter t, I'm going to go ahead and plug in 1.2. We're dealing with decimal values and squaring them. So there's certainly a possibility for you to go ahead and grab that calculator and multiply it out. I'm going to try to do it in one calculation here. So negative 16, parenthesis 1.2, parenthesis squared, plus 38.4, parentheses 1.2, parentheses plus 0.96, and hit the enter. I can get it all in one screen, and I am getting 24 as an answer. Again, one last time, application-wise, we were talking about in this question a height. We know in our problem that height is in feet. So I'll go ahead and put a label on this number 24 and understand that while it took 1.2 seconds for the apple to get to the highest location, to the friend on that balcony, that friend is catching the apple 24 feet above the ground.